Colby, 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 math.com.
Okay, we practiced fraction, addition, and subtraction today in class, and that's what we're practicing on this assignment. We have 3/4 plus 5/12 plus 7/18 on problem number 10, and so we need a common denominator. The lowest common denominator will also be the least common multiple of 4, 12, and 18. And of course we could use the Venn diagram model that we learned in our last unit, but sometimes if the numbers are small enough, it's easier. It could be easier just to consider multiples of the largest denominator, in this case 18. Neither fourths nor twelfths can become 18ths because 18 is not a multiple of either 4 or 12. But the next multiple of 18, 2 18s, which is 36, is a multiple of both 4 and 12. And so if you just convert your fractions into that multiple of 18 into 36ths, then you can add them. So fourths become 36 by multiplying by ninths. And I want my whole 3/4. I don't want the 3/4 to change, so I have to multiply by 9 ninths. You can only multiply by some version of 1 because you don't want the fraction 3/4 to change. You just want to represent it in a different form. If you multiply anything by 1, 17 times 1 is 17, 21 times 1 is 21, and so 3/4 times 1 is still 3/4. We're just going to represent it as 27/36. That's still 3/4. Why don't you, during the pause, try doing that with 5/12 and with 7/18. Convert those all into 36 by multiplying by the correct version of 1 whole in each case, depending on the denominator you're working with. And then once you have these all as 36, add them up, and then consider the forms given for these answers and try to simplify your expression accordingly, and then come back after the pause and see how you did.
Paused.
5/12 would need to be multiplied by 3/3 to get 36, and so 5/3 is 15. And 7/18 would need to be multiplied by 2/2 to get 36, and so here we would have 34/36. And I should have shown my operation. We're adding these. We would need a common denominator if we were adding or subtracting or comparing. Now that I have the same size pieces, they're all 36, now I can just add how many pieces I have. I have 27 and 15 and 34. I knew I did something wrong. I don't know how I got 34 here. I hope when you're watching the video, you do the same thing you do as when you're watching in class. If you're watching carefully and you see an error, I may not correct it immediately, but I want you to notice it just like you would in class, and either I will catch it myself and correct it in the video, in which case you'll sort of say, oh, I knew I saw that error, I noticed an error there. Or if I don't catch it by the time I finish the video, you should use a discussion board or contact me or something so that we can support each other just like we do in class, and I can make the correction and address it in class, the next class at the latest. But in any case, we have 27/36 and 15/36 and 14/36. For a total of, well, 7 and 5 and 4 is 16, carry the 1. 1 plus 2 is 3, plus 1 plus 1 is 5. So we have 56/36. But you know, you're not going to find that on this table of solutions. It doesn't mean this is wrong, it just means it's not in the form we're looking for yet. This is an improper fraction. It's more than 1 whole, since the numerator is more than the denominator. So first I'm going to turn this into a mixed number by taking away 1 whole, which would be 36/36. And if I take 36/36 from 56/36, that would leave me with 20/36. So that's 1 and 20/36. Because we see some of these solutions are given as mixed numbers, but you're still not going to find that solution yet because 20/36 can be simplified. Now, if you can look at 20/36 and simplify it directly, you can do that. I mean, if you recognize that the GCF is 4, you can do it in one step. That's how GCF can help us. 20 divided by 4 is 5, and 36 divided by 4 is 9. And so this, in simplest form, would be 1 and 5/9. Or you could use the method we learned where we do the prime factorization of the numerator and the denominator. 36 is 2 18s, 18 is 2 9s, and 9 is 3 3s. So you could take 20 36 and you could substitute the expanded prime factorization for 20, which is 2 times 2 times 5, and for 36, which is 2 times 2 times 3 times 3. And then when you cancel out common factors, 2 halves is 1 whole, this 2 halves is 1 whole, you get 5 over 3 times 3, or 5 over 9. So that's another way to get the answer here. You don't need to do the puzzle part. Could be fun if you have time. It creates kind of an interesting pattern. But at a minimum, what I'd like you to do is when you think you found your answer, at a very minimum, at least look up here and make sure you see it. Like I see 1 and 5/9 here, so I feel confident that I probably have the correct answer. If you want to do the shading part, everywhere you see 1 and 5/9, you would shade it according to what you see here for problem number 10. And so you shade this bottom left-hand corner for every 1 and 5/9 you see. I see one there. I see another one here. You'll get a kind of an interesting pattern if you shade all your answers according to the pattern that's given. But it could be time consuming, so if you don't have time for that, you don't need to do that part, of course. I'm not going to shade them all, but you get the idea. You'll also find whenever I do one of these, I make my answer key, and I might miss a 1 and 5/9 somewhere along the way if my pattern doesn't look quite right, and I'll realize and I'll go back and I'll say, okay, I need to fill in this square that I missed with this pattern, and you get a kind of an interesting pattern. Okay, thank you for watching the video. I'll see you tomorrow.